loans, that is borrowing. Okay, now the formula, right? The formula is we derived the formula for future value annuities. Like the one for present value is not examinable, but it also comes from our knowledge of sequences and series. Okay, but the other thing as well is that I'm sure you are aware from the compound interest formula that A is equal to P times 1 plus I raised to the power of n. Sometimes you may need to calculate that P, which is the amount borrowed or the amount invested. Okay, so use your knowledge of exponents, that P can be written as A times 1 plus I raised to the power of minus n. So we use this second formula because in present value annuities, a specific amount of money has to be borrowed. Okay, and that amount is P. Okay, and then it has to be paid off together with the interest over a period of time. So here, the amount is borrowed there, T naught. Okay, then in most cases, when you're dealing with the borrowing, in fact, I'll just say all cases, there is no way that you can borrow money and then on that day that you sign the paperwork, you start paying it off. It's not possible. Okay, you negotiate, in most cases, a month after the signing of the paperwork. So this case is very different from the one for future value, where you can start making a payment in terms of your saving immediately. For present value, you don't have money, so where are you going to get the money to start making a payment straight away? No way. So you start a month, at least a month after. Okay? So no payment is made at T naught. No payment is made. Okay? In most cases, the first payment is made at T1, which is a month after. Today is the 21st of July. If I go to a financial institution to borrow money, I won't start making a payment today. Okay? If I want the interest to be less, I have to negotiate to start paying 1 month from now, which means by the 21st of August, I must make the first repayment. If I delay by another month, that is to start making a payment in September, on the 21st of September, the amount that I borrow today will accumulate interest based on the compound formula for 1 month until I start making the first payment. So the more you delay making the first payment after borrowing, the amount will increase that you owe before you start making the repayment. Okay, usually it's wise to start making a payment at what? At T1. If you delay making the payment, maybe you start making up to T3, these first 2 months here, that amount that you borrowed here, it will accumulate interest based on this formula. Okay, that's how it works. Okay, so this P, if you want to calculate it, I don't want to go into the details, right? Use the compound interest formula. Where there is A there, you put X. Okay, where there is N there, you put 1. You do the same for T2. Okay, carry on up to N. You use your knowledge of sequences and series there, simplify and everything, you will come up to this. The derivation is not examinable. You come up to there. Okay, so your knowledge of sequence and series is required to do the derivation. So the formula for present value is P equal to X times 1 minus 1 plus I raised to the power of minus N all over I. That's the formula, this one here. And as you can see, it looks almost the same like the one for future value. That's why some learners, they make a mistake of using either of the two because they don't understand the concept of future value and present value. Okay? All right? Now, this P is the amount that's borrowed. Okay? This is the amount which is borrowed. That's the amount which is borrowed. and that amount will accumulate interest depending on the specific interest rate and the number of years that you have to pay it off. All right, so that's the formula which you're supposed to know. Obviously, the meanings of the other value or other letters like x is still the amount, or rather the regular payment per month or per quarter, whichever the case, right? So that's the meaning of that is the same. That's the amount which is paid every month, for example, or every quarter. And this n here, that n there, okay? Remember, the n represents the number of repayments, the total number of repayments, okay? And you know your I or what it stands for, so you'll be okay. So the P is the amount borrowed, that's the number of payments. And that X there, that's the equal payment made every month. Okay. Right. Now I want you to know that this X value, it remains constant like in the future value, whether an interest rate takes place in terms of change, that is the interest rate goes up or down. If the interest rate changes, it might change a little bit, but generally it remains constant. Okay. Right. I think that's it there. So let's move on to the application of the formula. So we have an example there from Platinum Net. Right. The good thing about present value is that if you understood how to play around with the future value annuity formula, then you shouldn't have any problem with the present value. Okay. The only thing that we have to do is to do the different types of questions on present value, because there are different types of questions. So this question says, Ms. Ngobu takes out a mortgage bond of 980,000 rand on a property at a rate of, okay, that's a mortgage bond. That's a sign that the person is borrowing to buy a house, okay? And so you've got 980,000, okay, at a rate of 14% per annum compounded monthly for 25 years. Okay, for 25 years the person has to pay it off. That's a long time. Okay, it's almost like a quarter of the lifetime of someone or half of the lifetime of someone. Okay, calculate the monthly payments. Yeah, calculate the monthly payments required to settle the bond if Mrs. Ngobu takes the first payment in 1 month's time. Right? Usually, the first payment has to be made in 1 month's time, in most cases. It cannot be made at T0. Okay? That's very important for you to know. It's very easy for you to make that mistake of including T0 for present value. Please don't do that. Okay? T0 can only be included if you are dealing with future value where you've got an investment or a saving taking place. So we want here it says the monthly, calculate the monthly repayment, so that's X. So we write out whatever we are given there, that's 980,000. The number of payments, okay, the timeline for this looks like that. So we have T0, 980,000 is given there. Okay, it's 25 years, so the interest is compounded monthly, so 12 times 25, that's 300. So that's up to 300. So the first payment is made here at T1, a specific amount is put. Right, so N is going to be 300, but how did I get it? It's 25 years times 12, which is equal to 300. Right, my X, that's the one I want. My I is equal to 14% over 12, which is 0.14 over 12. Okay, and then just have to substitute now those constants. So let me try to do it here. So my formula, P equal to x times 1 minus 1 plus I raised to the power of minus n all over I've got P. Right, I'm going to make x the subject. Okay? So if I want to make x the subject, it will be x equal to Pi all over 1 minus 1 plus I raised to the power of minus n. Okay? And then I need to substitute that. I don't have space. So I'm going to substitute just now. Next page. So my next page, I'll say x will be equal to P, that's 980,000 times 0.14 over 12 all over 1 minus 1 plus 0.1 over 114 over 12 raised to the power of minus 300. Okay. If you use the calculator, what do you get? 11,796, comma 86. Right. So you pay 11,796 and 86 cents per month.
So you're gonna pay that for 300 months.
Yeah, you paid that for 300. For 25 years, that is 300 times.
3 million.
Yes. This is how the banks make money. Okay. This is how the banks make money. Okay. And listen, the bigger the house, okay, number one. Number two, the area where the house is located will make the price of that house very high. Okay, the area is very important. Okay, if it's an affluent area, then the price will be very high. If the house is also big, the house will go up. So you can even pay more than this. Okay. Yes. So our x will be equal to, remember we can make this, will be equal to 1,800,000 times 0.125 over 12 all over 1 minus 1 plus 0.125 over 12 raised to the power of minus 240. Okay, like that. And then you simplify. It will be 20 what? Comma? So that person will pay 20,000 rand. Okay, 20,450 and 53 cents per month. Okay, that's per month for 20 years. All right. Yeah, that's how much you pay. Okay. Obviously, the house is quite expensive, 1.8 million. So it's a big house with some luxuries like a pool and stuff like that. Right? Let's move on to 3.2. Right? 3.2 says, determine how much interest Mr. Taylor will pay altogether. Determine how much interest Mr. Taylor will pay altogether. I don't like this word here because it can be misleading. Okay, the key word there is the interest. Right? Sometimes the wording of a question can cause one to misinterpret a question. Okay, once you misinterpret it, then you won't be able to do it properly. So you have to comprehend the question first, then you can answer. Okay, so let's calculate the interest. How would you calculate the interest that Mr. Taylor paid? From common sense, how would you calculate the interest? Yes, Brian.
Calculate the total amount you pay with interest and then subtract the original amount.
Yeah. So we need to calculate the total amount that the person had to pay, which includes interest. Then you subtract the value of P from that amount. Then you get your interest. Okay. So how would you do it? You need this value. Okay. Because that's the amount that the person is gonna pay every month for 20 what? For 20 years. Right? So you multiply that by what? By 240, because there are 240 payments. Okay? So let me do it here. Now, if you go to the next page. So 3.2 is gonna be the interest is going to be equal to 2450, 2450, 53 times 240. Whatever product we get, we subtract 1,800,000. What answer you get?
3,108,000.
3,108,000. Are you sure that that's the interest?
Yes.
3 million.
127.
127. Come on. 20.
Yes.
Okay, please. Just as a reminder, we are doing financial maths. You round off to 2 decimal places. You round off to 2 decimal places. Okay? It's financial maths. Because you may be penalized. If the memo is very strict in terms of decimal places, you can be penalized. So it's a silly mark to lose. Just round off to 2 decimal places, you are on the safe side. Now look at this amount. It's 3 million that you pay as interest if you borrow that 1,800,000. So in total, you pay in total, including that one, almost like 5 million. Okay? 5 million that you pay. And remember, when it comes to a house like this case here, when you buy it, you might need to have some kind of renovations to make it look nicer based on what you like. So you might have to spend an extra amount to make it look nice. Yes.
With bonds, is there like a minimum amount of years that someone can pay?